It is time for one more incredibly exciting, thrilling, stunning lesson in math. Sorry, I had to grab my coffee here because it's going to be a long one for you. Today we're talking about congruent and similar. If you're a geometry kind of person, this lesson is for you. You will know after this one whether you like geometry or whether you don't. And whether you like it or not, eventually you're going to have to take it. So you might as well just like it anyway. So here we go. I did give you, you should have a couple pieces of paper from Mrs. LeBeau. If you don't have those, please make sure you get them because you don't need to write all this down. It's better off if we kind of work through this together. So give you a second to make sure you have that. Grab something to write with. Let's talk a little bit of turkey here. We've talked a little bit about this before, but we are going to go super in depth with it now. First things first is today we're talking about shapes, and we are talking about similar and congruent. And we are starting off, first of all, with congruent. And basically, when we've talked about congruent before, congruent means exactly the same. Exactly the same. Now, of course, in the math world, we like to make things just a little bit tougher to understand. So here is the book definition of being congruent. Blah. The book definition of being congruent is congruent polygons have corresponding angles which are the same measure and corresponding sides which are the same length. To which you're going to say, what in the world is that? And here's the deal. Let us take a look at these three triangles. Triangle number 1, triangle number 2, and triangle number 3. And here's what they look like. If you're looking at, we're looking at, first of all, two things. We're looking at the sides and we're looking at the angles. Let's look at the angles first. Okay, if you look at this, angle B, angle E, and angle H are all, well, they're 90 degrees. Let's just go that. And the way we show in math that they're the same is we make this little arc. And if these all just have one arc, we mean those are the same. Angle A, angle D, and angle G are also both the same. So this time, because we already have a single arc, we're going to make those two arcs. Poof, poof, and poof. So that tells us those are the same. And angle C, angle F, and angle I are also the same. And since we have 1 and 2, this one we'll make with 3 little arc marks. How about that? That rhymes, arc marks. Okay, so these 3 triangles all have exactly the same measurements for their angles. Okay, and when they talk about, well, let's do sides first. Now let's look at their sides. Here is where things get a little snarky for us again. Angle AB and angle DE are the same. We'll put a little tick mark there to show that they're the same. Now notice that the one, this angle, this line GH, I'm sorry, did I say angle? Angle AB and angle DE, side AB and side DE are the same. That's why we put one tick here. But this side GH is not the same. You can tell that's a little bit longer. Same thing with side AC, put 2 marks there, and DE are the same, but GI is longer than those. And side CB and side EF are the same. Okay, and they are shorter than IH, so those are not the same. So with that being said, here is the deal. We know that because this setup here, congruent polygons have corresponding angles that are the same and corresponding sides. They both have to be the same. So here is what mathematically, how we would write this. We would say that triangle ABC is congruent to, and this is how in math we write congruent. We do an equal sign and a little squiggly line up here. Triangle ABC is congruent to triangle DEF. They are exactly the same like we wrote up here. They are exactly the same. Now, just so we're all on the same page, when we talk about corresponding, maybe a different word for corresponding are maybe the sides that match up. or the angles that match up either way. All right, which means this. The corresponding angles here, and we're just going to be talking about triangles, these two triangles here. We're going to kind of leave this guy out because he is not a congruent triangle. Corresponding angles look like this. Angle C, we put our little angle sign, corresponds to what angle? Angle F. Angle B corresponds to angle E. And remember, we can put just a single letter here. Usually when we name angles, we have to label all three, but in a shape, you can't really mix up angle C. It is the only option you have for that. So that's why we can do that. And then angle A corresponds to angle D. Sorry, my D is a little goofy there. If you're looking at corresponding sides, it's kind of the same thing. Side AB, put a little line up there to show it's a sign. It corresponds to side DE. And EF, you probably are getting the picture now, corresponds to AC, or BC, sorry. And AC is corresponding to DF. And there you go. Those, ladies and gentlemen, that gets you kind of the gist of that. And that's really all you need to know about congruent, because congruent means they're all the same. So there's not much to do with congruency. What we're really talking about today is if you take out Jan Fair next piece of note paper, the one that says similar, this is really the nuts and bolts, the potatoes, if you will, of today. Today, we're speaking about similar. Okay, now similar, when we talked about similar before, when we defined it back in 6th grade and even in 5th grade, similar are shapes that have, how we said it was, they have the same shape, but not necessarily the same size. And then we use that word that similar shapes, I'm pretty sure we wrote this, similar shapes are proportional. And we talked about thinking about a balloon. To be proportional means as something gets bigger, as it dilates in our mathematical world, the sides get bigger at an even rate. They're proportional. As one gets bigger, the other gets bigger at that equal rate. Okay. So here's some definitions from the book for you to realize or look at. Similar polygons have corresponding angles which are the same measures and corresponding sides which are proportional. Okay, and that kind of goes down if you look at this next thing here. Okay, if you have corresponding sides to a shape, if you have proportional corresponding sides, those triangles will be similar. And here's how you figure that out. Let's take a look here. This says which two triangles are similar, or which two quadrilaterals are similar. And what you look at is this here. Okay, first of all, looking at their angles. Okay, if you look at this here, what do you have as far as angles? Well, look, here is an 80-degree angle. Here's an 80-degree angle. 100-degree, 100-degree, and 80, 100, and 100. Okay, those, if they have the same angles, if two shapes have the same angles, they are going to be similar. They will be similar. Same thing for this. This has two 80s and two 100s. Okay, all three of these shapes are similar because of that angle, that whole, what's it say? I guess side angle thing here somewhere. Maybe it's down here at the bottom. Might be on the next page. We'll get to that. This one over here, okay, also has two 80s and two 100s, but they are not in the same places. Okay, they're not in the same places. They need to be, notice how these are diagonal and those are not. So this would not be a similar shape. Okay, And then the other thing you need to realize, for things to be similar, okay, for things to be similar, their sides have to be proportional. So if you look at this, if you look at the, I'm going to erase this so you can actually see it a little bit better, because now I got all this stuff here. If you look at this, okay, and you look at side 4 is the short side on this, so it corresponds to the side, the short side over here. Okay, 2 short sides. You have corresponding sides are proportional. What that means is this: how do I go from 4 to 8? I multiply by 2. Okay. Now, if in order for a shape to be proportional and similar, every other side on this small one would have to be multiplied by 2 to get to the big one. That makes it proportional. So you look at this side 6, the long side. If you multiply it by 2, do I get 12? I sure do. So that makes those proportional. Okay. Now, what about this little rectangle here? It's a little tougher to tell because the scale factor is not super exact. I mean, it's not like an even number, but if you look at the small sides, how do I go from 4 to 6? By the way, here's a little math lesson for you. Here's a question. What I just asked you is this: 4 times what number is 6? How do I solve that equation? Remember, you think of some simpler thing, or just think of the opposites. I divide by 4. It's not a pretty answer, but what it is 4 goes into 6 1.5 times, or 1.5. And that would mean if I multiply 6 by 1.5, I multiply 6 by 1.5, do I get 8? I certainly think I do. 6 times 1.5 is 8. Okay, so based on all of that stuff here, they are proportional and they have the same angles. These 3 shapes are similar. Okay, and then to add on to that a little bit down here, we come up with this side, side, side. Now notice this is triangle similarity. And that simply says this: if 2 triangles have proportional corresponding side lengths, then the triangles are similar. Okay. If 2 triangles have proportional corresponding, and that's the same thing we just talked about. In other words, you have to think about what sides correspond, and what happens is the small side corresponds to the small side. What is the scale factor, or what do I multiply 4 by to get 8? I multiply by 2, which would mean all the rest of these, if they are similar, when you multiply them by 2, you will get those answers. And that is true. So these triangles are similar. Now, if you remember, our little symbol for congruence was that equal sign and that little wavy little thing. If you're talking about similar, this is what similar looks like. Triangle ABC. The similar mark is without the equal sign. It's just that little wavy little thing. Triangle ABC is similar to triangle DEF. Triangle ABC is similar to triangle DEF. Now let's go on to some more exciting things. We're almost done. And then we have this angle, angle, angle similarity. Notice the other one was side, side, side. If the sides are proportional, then they're similar. The second thing is if the angles of one triangle are congruent. Similar things have congruent angles to the angles of another, then the triangles are similar. So if you look at these 3 triangles, and these 3 triangles all have 20, 60, and 100 degree angles. 20, 60, 100. 20, 60, 100. Sorry, 160. Okay, if that is the case, all 3 of those are similar. Okay, if they have the same angles, they have to be similar. There's no other option there. Okay, so now let's put this into a little bit of practice here, and this goes back to yesterday, our little math class, when we talked about equal ratios, because proportional things form equal ratios. They're proportional. If you are looking for the answer to this problem here, Okay, the triangles, first of all, you have to know that the triangles are similar, which tells you that it is proportional. Sorry about that ugly line. Okay, the triangles are similar. It says to find x. Okay, so here's what you need. Just like yesterday we talked about solving proportions, we need ratio boxes. And my ratio box is not very good, but I'm going to do it here. And just like yesterday, it's very important that you label this. We're going to put these, this was the ratio. And you can put the ratio, well, actually, because we're dealing with triangles here, it's probably better to do this. We've got the small triangle and the big triangle. And then we are going to put what sides we're talking about on this. And you need to pick two that you know first, or one that you know and one that you don't know. I don't know. I could pick this one, which is the longest side. So let's label this the longest side. And then the one I don't know is the short side on the big triangle. So it's going to look like this. The long side on the short triangle is 5 inches. The long side on the big triangle is 15 inches. The short side on the small triangle is 3 inches. And the short side on the long triangle, I don't know, that is x. And if you remember when we did this yesterday, okay, I told you these are just nothing more than equal fractions. Okay, you can just simply do this. How do I go from 5 to 15? You multiply by 3. So to go from 3 to there, you multiply by 3 as well. So 3 times 3, x has to be 9 inches. So x is 9 inches over there. So that, ladies and gentlemen, is similarity and congruence in a nutshell. I hope you've enjoyed that. We'll get lots of practice at this as time goes by. So with that, ladies and gentlemen, I bid you a fond farewell. Enjoy the rest of your day.